Now dear student, we are going to discuss question number 1.29, and in this question it is given a hollow charge conductor has a tiny hole cut on its surface. Okay, fine. Show that electric field in that hole is sigma upon 2 epsilon naught n cap, where n cap is unit vector in the outward normal direction and sigma is surface charge density near hole. Yes or no? So now concentrate on a screen. Let's suppose I am taking here an example of a sphere. Clear? We can take any example of a conductor. So let's suppose we have this hollow sphere. Let's suppose like this. Clear? And let's suppose if I am talking about an outermost point, let's suppose this is a point P. Clear? And let's suppose actually I cut a small part on its surface. Clear? So let's suppose this tiny hole is cut on its surface. Clear? It means this part is removed. Clear to everyone? So now if we talk about total electric field at point P by all the we can, if we are assuming complete sphere, so total electric field at point P, this is given by, let's suppose I am assuming this as 1, and let's suppose this sphere I am assuming this is 2. Clear? This one is 2. Clear? So let's suppose if I provided here a charge that is plus q. Clear? So we can say electric field due to 2, we can say in this direction this is E2, and due to 1 we can say this is E1. Clear? Now we know if we have a charge conductor, electric field outside at any point, this is given by E equal to kq upon r square. Clear? R is the distance of that point from a center. Clear? So we can also write like this, 1 upon 4 pi epsilon naught into charge q. We can say, we can write in terms of surface charge density sigma into surface area, we have 4 pi r square and it is divided by r square. So r square and r square, this is cancelled out, 4 pi and 4 pi cancelled out. So from here we can say E, this should be equal to sigma upon epsilon naught. So my dear student, this E is what? This is E net. Clear? And this E net actually consists of two electric field E1 and E2, and both are in same direction. So we can write like this, E1 plus E2, this should be equal to sigma upon epsilon naught. And most important, let's suppose we are assuming unit vector in the outward direction, that is n cap. So we can write like this, this is n cap and this is net electric field. Yes or no? So this is value of net electric field that is outside. Clear? And let's suppose this is equation number 1. Clear? You can write like this. Yes or no? Now if we consider at any point, let's suppose I am considering here point number q. Clear? Now we know inside a conductor we always find net electric field 0. Yes or no? So we can say, let's suppose this is E1 and let's suppose this is E2. So we can say here E1 and E2 definitely will be in the opposite direction, so that we will find net electric field, this should be 0. So this is equal to E1 minus E2 and it should be equal to 0. Clear? So from here we can write like this, E1 this should be equal to E2. Clear? So now if we utilize this relation in this equation, how can we write? So we can write like this. Actually here we are just writing magnitude because direction is opposite, so E1 equal to E2. Clear? So if we talk about magnitude, we can say E1 plus E2, this should be equal to sigma upon epsilon naught. Clear? And direction is along the vector, that is outward, normal outward direction, this is n cap. Clear? So we can write like this, 2 times of E1, this should be equal to sigma upon epsilon naught, and we can say E1, this is given by sigma upon 2 epsilon naught, and most important, if we write in a vector form, this should be n cap. Yes or no? So value of E1, this is given by sigma upon 2 epsilon naught and n cap. Clear? So this is answer and this is the proof of this question. Clear to you? Yes or no?